This is part 5 of the FACIT N4000 paper tape punch restoration. Today I want to look at the punch head itself, but before I do that I just want to make a quick update to the previous video. I wasn't too happy with the way that the tape was feeding onto these spools, so I've replaced the bracket I showed in the previous video with a modified one, and this just moves the two spools, two rollers, a bit further towards the rear of the machine. And the reason for doing that is to give a bit more clearance on the actual tape reel itself. The tape was getting a bit too close when it was running. Let's feed the tape through. So now there's plenty of clearance between the reel of paper and the tension roller, whereas before with the rollers this way this was a bit too close and it was catching on the platter, whereas now, as you can see, there's plenty of clearance. Okay, so that's just a quick update to the previous video. I'll move the machine out of the way and get the print head on the bench. This is the punch head assembly. It's a very nicely designed piece of kit. It's fairly unusual compared to most of the punch heads I've seen in the past. Most of the ones I've worked on previously have a constantly rotating mechanism, and the solenoids that operate them generally are used to engage or disengage particular pins with that rotating mechanism to determine whether they punch or not. But this head uses direct punching, so each of the solenoids is connected via a rod to a pivoting assembly here, and when the solenoids are energized they push these pins, and then through a rocker that pushes the pin and it punches through the tape. I've partly dismantled it here so I can fully test it and make sure it all works. So far I haven't found any faults other than a few adjustments that were needed. The way it's used is paper tape is fed through the punch head. I mentioned on the previous video that there's a release lever that releases the pressure between the pinch roller and capstan, and that's what this is when it's pulled. And this is normally pulled by that thin wire that we saw attached to the tape feed mechanism. When this is pulled, it allows tape to be freely fed through the head, and when it's released, it's obviously the tape is obviously captured between the pinch roller and the capstan. If we look on the back, we can see the actual punch solenoids. These are rotary solenoids, so unlike most solenoids that you may see where when they're energized the plunger is pulled into the solenoid, on these particular solenoids when you energize them it causes the particular core of the solenoid that you energize to rotate. So if I rotate this one, you'll see that it just turns by about 45 degrees, and then when it's de-energized it pops back. Now, because I operated that one, in theory we should have actually punched the tape. So if I withdraw the tape from the punch head, so I can press the release lever, you can see that we actually punched a hole in the tape. Normally the solenoids of course operated under control of the microprocessor in this machine. This punch head will accept different widths of tape. So you can see that on this little spring guide there are little notches for the different widths, so this head will accept everything from 5-hole tape up to 8. But also because all the pins are attached to a solenoid, it can actually punch 9-bit code where the sprocket hole can be used to code data. I've never actually seen that used, but apparently this punch can do that if you want it to. This assembly down here is the capstan drive motor. It's effectively a 3-step per revolution stepper motor, very low inertia, and the device on the bottom is a braking system, and that makes sure that the capstan can only move into very discrete positions. It's each time the stepper is stepped, then this assembly at the bottom is used to make sure that the tape advances by a particular amount, and as I move this, you can see the tape is coming through the head. All the solenoids are wired up through this board. Nice feature about this punch is that everything is plugged together, so you can just easily get assemblies out. Most machines I work on of this vintage, everything's hardwired in and a real pain to work on. But you get full access to this. Now, I've been through this mechanism, I've tested all the solenoids, they work fine. I've lubricated and adjusted the solenoids. A couple were out a little bit, but mostly I don't think this has had much use because there's very little adjustment needed. So what I'll do is I'll screw this board back in place, and then I'll connect up some signals so we can actually drive the punch head and just make sure everything's running smoothly before I reassemble it and put it back into the machine. Okay, so I've reattached the board to the punch head. As I say, I've checked the alignment and operation of all these solenoids. The way they're wired up is for the stepper motor there's a common ground and a separate lead for each of the 3 coils, and for the actual punch solenoids there's a separate feed and return line for each one. These devices on here are actually fuses, and it's nice to see that each particular punch solenoid has a separate fuse, so if you get a fault with something it's not going to take out the drive board. At least I hope it hasn't taken out the drive board should there be any faults. So what I'm going to do now is connect some signals up to the stepper motor and see if we can get it to drive. I just want to make sure it spins freely and we don't have any binding or any issues with it not being able to turn. So I'll connect it up and we'll flip it over so I can see the actual drive motor side. Okay, so the drive motor spindle comes down through here. You can see it's very low inertia, very slim spindle, so there's very low rotating mass on here. And the way this works is this is just a split core solenoid, and there's a vane down here, and each time you energize one of the solenoids then it pulls the vane into the slot, and the vanes are all offset 120 degrees from each other, so if you energize these in the correct sequence you can get the motor to spin in one direction or the other. Now I've got this hooked up to my Rigel DP832 power supply. The DP832 is quite nice in that it has a program capacity for each of the 3 channels, and at the moment I've got them configured so that they will cycle through what effectively is a 3-phase drive signal, and then each pulse is spaced by 1 second. So in other words, this should step 1 position each second, and we should be able to see the shaft rotating. So, okay, the power supply is set and ready to go. What will happen when I switch it on is that each of the 3 solenoids will be pulsed in sequence, and we should see the shaft in here rotating, and it will go through a 120 degree step once every second. Okay, so I'll turn on the supply. As we can see, it is driving, and you can see that the tape is coming through the machine. Being 3-phase, if I reverse any 2 of the connections, which is what I'm doing now, you'll see the tape drives in the other direction. And this machine apparently has the capacity to back up the tape. I'm not quite sure why you'd want to do that. I suppose you could make some minor corrections, but I've never seen a punch tape drive where I've needed to actually do that. Okay, so that's the basic stepper operation, but that's only part of it. This shaft then goes up into an offset drive, and the offset drive is a sine drive, so what it does is, although this is stepping quite quickly, I think it takes about 10 milliseconds per step, in order to stop the tape slipping by trying to overdrive it, in other words, you don't want to try and drive the tape with a very rapid acceleration and deceleration. So this mechanism, which we can't actually see, it's kind of an offset pin drive, but it results in the, if you imagine, square wave type drive in terms of the acceleration being translated into a sine type drive. So it smooths out that torque peak, and it pulls the tape more smoothly through the punch head, cuts down on the likelihood of a miss punch, and also makes sure that the spacing of the rows is much more even, so you get much higher quality punching. Okay, so that's the punch head tested. I'll reassemble it and put it back into the machine, and then we'll see it driving the tape through the machine from the tape feed. So I'm in the process of refitting the punch head to the machine, and one of the things I noticed when I took the machine apart was that the cable coming from the tape feed assembly was way too long. Let's pull the tape back out of the way a little bit. So I mentioned in the previous video that there's a lever on the punch head that allows the tape to be released, and that's so that it can be loaded easily. So in this relaxed state, it's very hard to pull the tape through the head. When you push this lever in, it lifts the pinch roller off the capstan, and then the tape can be easily moved in and out. And in order to facilitate loading of the tape, I mentioned in the last video that there's an assembly back here in the tape feed unit, so that when you load the tape, you move this lever all the way across and it engages with this magnet and puts it into the tape load position. That also, through these linkages, pulls this thin cable. So as the lever is moved, I don't know if you can see it clearly enough, it's pulling this cable back and forth. So if I move it across into the tape load position, it pulls the cable in. But the cable's way too long, it's just flopping about, and when I took it off it was wrapped a couple of times around this lever. So I don't know if it's stretched or if it's always been like that, or if it's been replaced or whatever, but I wasn't really happy with it being like that. So what I'm doing is adjusting the length of the cable. So I've uncrimped, these are just copper, a short length of copper tube that are being used to pinch onto the cable to set the length. And to adjust it, all you need to do is uncrimp them, so they're normally squashed flat to hold the cable, but if you squeeze them the other way to try and get them back into a circle, it will release the cable. So I can now pull the cable through. So what I've done, I've adjusted the arm adjuster into the central point, so there's a slot in the arm that enables you to adjust the spring tension. I'll put that into the center. It doesn't adjust the stops, it just adjusts the amount of spring force. And then I'm going to hook the cable onto the little boss underneath the arm, pull the cable through the little olive crimp there, and then I want to put the release arm a little distance away from where it's going to be put when it's in the tape load position, and that's the location I'm going to use the correct length for the tape. So what I can then do is pull the cable through, just making sure it's in the correct location on the tape feed mechanism. Okay, I can then pull the cable through. So I don't want to pull it out of the olive, otherwise I'd never get back through again. Okay, so check again that the cable's in the correct location at the far end. And to check it, what I'm going to do is just hold both parts of the cable with the pliers, kind of simulating that I've actually crimped this, and I'm going to move the load lever into the correct location and see if I can move the tape, which I obviously can. Probably a little bit tight still, so it needs to come a bit further. So what I'll do is I'll move the lever a bit further than it was, retension the cable, grab both parts again, put the lever back into the load position, and that's better, and we can now move the tape freely. So what I can now do is crimp it in that position. I'll relieve the tension on it so it doesn't move. I'll take it off, I can now crimp it, and that will give me the correct length for this cable. Don't know why it was the wrong length in the first place. You can see it's quite a difference in length. I doubt it's stretched that much, but it's possible, I suppose. So I'll crimp that, get it refitted, and then come back on camera and show the overall assembly, and we'll try and drive some tape manually through the machine. I now have the tape loaded as it's supposed to be. We'll have a look at the reel dispensing in a few minutes. I've got the same signals hooked up to the punch head that I had before, so I can manually drive it, albeit very slowly at 1 step per second. The tape tension looks fairly good. As I say, I've crimped and trimmed the release cable, so that's now at the right tension, and it operates in the right position relative to the tension arm. So if I now start the stepper motor running, we can see that the tape is advancing through the machine as it's supposed to. If I move us to the back, you can see that the tape tension is doing what it's supposed to. It's staying within the sector it's supposed to run in, and you can see that the reel is being released slowly as it should be. I'll just reset the power supply to run it again, set to just run a few times and then stop. Okay, so it's running again. So you can see that with each step, this is very subtly adjusting the position of the tension lever, which in turn is releasing and applying the brake on the reel. That's allowing the tape to be pulled off at a fixed tension, then goes through the print head, and it's obviously being fed through as it should be. So we've now got the tape feed working as it should be working. The print head seems to be tested and is behaving the way it should. I can't pull the tape through manually with it in this position, but if I now move the tension lever across into the tape load position, you'll see that as I approach the magnet, which I'm getting close to now, it starts to pull this, and then it releases the tape tension. So that allows you to load new tape in, and then if you lift the lever off the magnet, it then immediately recrimps. It's quite a small adjustment. It's within probably about 1 inch of the magnet when it re-grips the tape. I don't know if that's right or not. As I say, I don't have the manual for it, but it does seem to be working the way I would expect. Okay, so that's it for this video. In the next video, I'll start looking at the electronics and see if we can get the unit to come to life. I don't know if the electronics work at all, or to what degree. I haven't tried powering this up from the mains yet. But so far we've been fairly lucky with the electromechanical side. A few adjustments, a few components need to be made, but we're now getting close to what is a properly functioning print head assembly and machine. And if we're as lucky with the electronics, then we're fairly close to have a fully functional FACIT N4000.